Okay, we are on 10-8, vertex form of a line. The vertex form of a quadratic function is given by f of x equals a times x minus h squared plus k. This is something that is not given to you on your exam, unfortunately. But there's not a ton of questions that I've seen on past exams where they do ask these questions on vertex form. Some exams do have questions, but it's not a huge, very, very important topic. HK is your vertex. So this value here and this value here give you where your vertex is. I'll just go through these little notes down at the bottom here. When written in vertex form, h comma k is the vertex, and x equals h is the axis of symmetry. So again, just taking that x value, or in this case, the h value of your vertex to determine where the axis of symmetry is. These next things aren't super important, but good to know. The h represents the horizontal shift, how far left or right the graph has shifted from kind of its original form. We talked about horizontal shifts and vertical shifts in our functions unit. And then the k is a vertical shift. It's either going up or down from the original form. Notice that the h value is subtracted in this form and the k value is added. So in this equation, y equals 2 times x minus 1 squared plus 5, h is 1, and k is 5. So just notice that the h value is positive 1 because there's supposed to be a negative there already, coming from that vertex form at the very top of the page. But if we have a plus here, your h is actually going to be negative because it's the opposite sign of what the original form lays out for us. And then the negative here for the k is -6. Okay, first example, find the vertex form of the quadratic function y equals x squared minus 4x plus 3. This is a lot like the process of completing this square, and I'll show you why in a second. I'm just going to write at the top of this page what vertex form actually looks like. So we want to get this in a times x minus h squared plus k. Okay, so we're going to take our function, set it equal to 0. And think completing the square. So we want to get the constant to the right hand side. X squared minus 4x. We're going to add some value and then -3 and add some value. Remember, to fill in those spaces, we need to take half of our b term. So half of -4 is -2, and then square it to give us +4. So we are going to fill in +4 in those spaces. Okay, we're going to complete the square on the left-hand side, so factor that. I'm going to use the shortcut. It's going to be x minus 2. Again, same sign. Half of the b value, half of 4 is 2. Squared equals -3 plus 4 is going to give us 1. So notice right now I have the x minus h squared part of the vertex form on the left-hand side of the equal sign. All I'm missing is that constant. So to move the 1 from the right-hand side to the left-hand side, we're just going to subtract 1, and that's going to give us x minus 2 squared minus 1. Okay, that is now in vertex form. Now the a in the vertex form equation or formula, you might not have an a there. In this case, for example, 1, the a would be 1. Sometimes we will have a number on the outside of that parentheses, but in this case we did not. Number 2, find the vertex form of the equation. Okay, again, I'm going to set this equation equal to 0. Actually, I lied. Sorry, just looking at my notes here. Okay, so we're actually going to leave this in y equals form, what we're going to do is get that get that negative 1 over to the other side of the equation, so add 1 to both sides. That's going to give us y plus 1 equals 2x squared plus 6x. Now, hopefully you're noticing that we can, on this right-hand side, we can factor out a 2 from here. What I don't want to do is take a GCF of the x out, because it's not going to allow me to factor the correct way when we go through kind of the completing the square process. So I am going to factor out a 2 here. If we divide each of these by 2, we're left with x squared plus 3x. But then I'm also going to be adding that value when we take half the b term and square it. On the right hand side, we need to take that into account as well. This time we're not just adding the value that we're going to find, that half b and square it. We're actually going to be doing 2 times that value. And that is because we just took out a common factor of 2 there. Okay, a little confusing, but hopefully you can follow along, and we actually do this in the next example as well. Okay, so now we need to take half the b, which is 3, and square it. So half of 3 is 1.5. If we square that, we should be getting 2.25. So in my spaces, I'm going to have 2.25. So y plus 1 plus 2 times 2.25 equals my common factor of 2, x squared plus 3x plus 2.25. Okay, from there I am going to evaluate this 2 times 2.25, and I'm going to add that to 1. Okay, so 2 times 2.25 is 4.5. If I add 1 to that, that becomes 5.5. And then I am going to use that trick again to factor this polynomial in the parentheses, that trinomial. Remember, it's going to have the same sign as the b value, and half of the b value is going to be the number that goes in the second position of the set of parentheses. So half of 3 is going to be 1.5. And then finally, if I want to get it into that vertex form, remember it looks like this. Okay, my right-hand side has my a times the x minus h squared. What I'm missing is this plus k. The way that I get that k value to the other side and to get y by itself on the left-hand side is we need to subtract 5.5 from both sides. Okay, so my final answer for this in vertex form is going to be y equals 2 times x plus 1.5 squared minus 5.5. And now that is in vertex form. But the question is asking us to find the vertex of this equation. So I need to look at the h and I need to look at the k. So remember, in front of the h is supposed to be a minus sign. We have a plus sign in our answer. So our vertex h value is actually going to be negative 1.5. Again, because it's the opposite sign than we have in the vertex form formula. And then your k, remember, is supposed to be a plus. We have a minus, so that is also going to be a negative 5.5. Okay, so final answer, our vertex is at negative 1.5, comma, negative 5.5. Okay, number 3. I know you can't see the actual question on my screen, but it says, let's analyze the quadratic 2x squared minus 4x minus 16, which is written in standard form. Part A says, write the function in vertex form and state the coordinates of its turning point. Remember, the turning point is just another word for its vertex. So let's get this into vertex form first. So our original equation is 2x squared minus 4x minus 16. We're going to be doing the same thing that we did from the previous example. So move the 16 by adding it. That becomes y plus 16 equals, oops, sorry, I'm just going to leave room because I am going to end up adding something on this side. Equals 2x squared minus 4x. Okay, again, we want to take that common factor of 2 out. We don't want to take the common factor of x out. That's not going to allow us to factor that inside of the parentheses using trinomial factoring. So this will say y plus 16 plus something equals, and I'm taking that 2 out. If I divide each of these by 2, I get x squared minus 2x. But then remember, I'm going to add that half my b term when I square it. Okay, half of our b here, so our b is negative 2. Half of negative 2 is 1. And then if I square 1, I get 1. So we're going to add 1 to both sides. Just don't forget here, you have to multiply that by 2 because of the multiplication of 2 here. The 2 that we took out is our GCF. Okay, just going to do some simplifying. Y plus 16 plus 2 times 1. 2 times 1 is just 2, so we're going to have y plus 18 here equals 2 times, and I'm going to use that trick again. It's going to be x minus, same sign, half of this gives us 1 squared. So I have that first part of my vertex form. Only thing that's missing is I need to move the 18 to the right-hand side of the equation by subtracting it. So my new form is going to look like y equals 2x minus 1 squared minus 18. Now comparing this to vertex form, my h is going to be 1, my k is going to be negative 18. So our vertex is going to be at 1, negative 18. Now you could double check this by plugging the original equation or the quadratic into your y equals, graphing a picture of it, and then using that minimum maximum function on your calculator to see exactly where the vertex is. Okay, so B says use your answer from A to find the zeros, which means we need to solve this quadratic for x. So if we're finding the zeros, we're going to take our vertex form and set that equal to 0. So it's going to say 0 equals 2 times x minus 1 squared minus 18. First thing we need to do to get x by itself is we need to add 18 to both sides. So we get 18 equals 2 times x minus 1 squared. I am going to divide both sides by 2 so that I can get x by itself a little easier. What you don't want to do is you don't want to distribute the 2 in because you're not following PEMDAS, and then you're making your life a lot harder. So this is going to say, I'm just going to continue this down here because I don't have a ton of room. 18 divided by 2 is 9. And then I'm left with x minus 1 squared. Okay, get rid of that squared by taking the square root of both sides. That's going to cancel with the squared on the right-hand side to leave us with x minus 1. Square root of 9 is 3, but don't forget you need to put a plus or minus in front of that. Finally, just add 1 to both sides to get plus or minus 3 plus 1. And then if we want to split that up into our two solutions, one is going to say 3 plus 1. The other one's going to be negative 3 plus 1. So we get 4 and negative 2. So those are our two solutions. Letter C says determine the function's y-intercept. A y-intercept is where the graph crosses the y-axis. Hopefully remember that at a y-intercept, your x value is going to be 0. So all we need to do is take our formula that was in vertex form, which is from letter A, and we're just going to plug in 0 for x. All you need to do is type this right-hand side straight into your calculator exactly how you see it, parentheses and all, and you should be getting -16. So that means that this graph is going to cross the y-axis at -16. Letter D says draw a rough sketch of the function on the axes and label all quantities in A through C. If you kind of put this in your calculator, you can see a sketch of what it looks like. But using the things that we know that this is going to cross the x-axis because we found our two solutions to be at -2 and +4. We know that this is going to cross the x-axis at -2. So I'll say that's like here-ish and +4. I'm just going to label these -2 and 4. We also found that it's going to cross the y-axis at -16, so maybe there. And we also found our vertex to be +1, -18. So that might be somewhere like here-ish. So it looks like this is going to be a parabola like that. I know I didn't go completely through that -2 solution, but again, you could compare that drawing to the picture of the graph on your calculator. Now, last step says, let's see if we can go in the opposite direction now. So what this is asking you to do is take that vertex form and get it into the normal quadratic standard form that we're used to seeing. Okay, so we're just going to follow PEMDAS here. Let's take care of the exponent first. When we're squaring x minus 1, that means we're multiplying it by itself. I'm going to FOIL this and then distribute my 2. Remember, you have the option of distributing the 2 to just the first set of parentheses and then FOILing. But if you're going to FOIL first, we're going to get x squared minus x plus 1 minus 18. I'm going to combine those like terms in my parentheses before I distribute. So we get -2x. Now I'm going to distribute the 2 to get 2x squared minus 4x plus 2 minus 18. And finally, I'm going to combine these like terms to get 2x squared minus 4x minus 16. Hopefully you are noticing that's the exact same quadratic that we started with at the very top of this example. Okay, number 4, the quadratic function pictured has a leading coefficient equal to 1. Answer the following questions based on your previous work. So they're giving us the picture of the graph here. Write your equation in vertex form. So vertex form again looks like this. Okay, obviously to look at the picture and write this in vertex form, we have to know what the vertex is. That's going to be this bottommost point here. This point is -1, -4. Remember, that's your h, k. Okay, it says it has a leading coefficient equal to 1, which means we're not going to have an a value. Our a value is just going to be +1. So I'm going to kind of disregard the a right now. X minus h. So x minus -1. If we subtract -1, that's the same thing as adding 1. So that sign is going to change to a positive there. And then our k value, if we add -4, that's the same thing as subtracting 4. So that is in vertex form. Okay, now letter B is asking us to get this in quadratic form. So we're just going to, again, use PEMDAS on this vertex form to get it into that quadratic form that we're used to. Okay, so I'll just rewrite it here. Actually, let me write out my squared portion here. So if I'm squaring x plus 1, that means x plus 1 times x plus 1. I'm going to FOIL x squared plus x plus 1 minus 4. And then finally I have two sets of like terms I can combine here to give us x squared plus 2x minus 3. How could you establish that these were equivalent functions? One way you could do it is we could kind of work backwards. Okay, we could take this quadratic form and get it into vertex form. Another really easy way to figure out that these are both the same line, both the same parabola, is just to graph them both in your calculator to see if you get the same exact picture. So graph both in calc to see if you get the same parabola. Okay, last one, number 5. Determine and state the vertex using the method of completing the square. So we're going to start doing completing the square until we kind of get to that vertex form. Okay, so first thing I'm going to do is I'm going to set this equal to 0. So we can start completing the square. First thing is add the 8 to both sides. Get that constant to the right-hand side. I'm going to leave room for that value I'm going to add to both sides. Remember, to find that value, we need to take half your b term, which is -2. Half of that is -1, and if I square that, I am adding 1 to both sides. So that's going to say x squared minus 2x plus 1 equals 8 plus 1. I'm going to use the shortcut here. This is going to say x minus half of this is 1 squared, and 8 plus 1 is 9. Now, before you go any further, notice on the left-hand side we have the first half of vertex form. Next thing we need is this 9 to move over here. So if we subtract 9 from both sides, x minus 1 squared minus 9 equals 0. And remember, this is what vertex form looks like. And our vertex is going to be h comma k. Our h value is 1. K value is -9. So it looks like our vertex is going to be at 1, -9. Make sure you go back to any part of the video you need to watch again. Make sure you're using the play and pause button as needed. Probably wouldn't be a bad idea, like I've said before, to just try maybe one or both of the homework questions on the next page to make sure you're good to go.